All right, so in our last breakdown, we got into what a backend is and how APIs are the messengers that make it all work. But, that's really only half the picture. Today, we're diving into the other, absolutely crucial half, the part that actually gives our apps a memory: databases. And I promise you, once this piece clicks, so much of backend development is just going to make perfect sense.
And honestly, this is the perfect way to think about it. The back end is the brain, right? It's doing all the processing, all the heavy lifting. But without a memory, without a database, it can't remember a thing. It wouldn't know who you are, what you bought, or that note you saved 2 seconds ago. It's a total blank slate every single time. So today, we're going to build that memory.
So let's start at the very beginning. Why do we even have these things? I mean, why go through all the trouble of setting up a complex system like a database? Well, it all boils down to solving one simple, universal problem: how to remember information. And in our world, we call that information data.
And what is data, really? It's not some big, scary concept. It's your username so the app knows it's you when you log back in. It's the email you signed up with. It's the status of a to-do item, whether it's in progress or done. Literally every little interaction you have online creates data that needs to be stored somewhere so it can be used later.
Now, way back in the day, before we had these fancy modern databases, developers would just, stuff this information into simple files, like text files or spreadsheets. And as you can probably guess, this was a complete and utter disaster. Just imagine trying to find one user's info in a single text file with millions of names. Or what happens when 2 people try to write to that same file at the exact same moment? Chaos. And security? Forget about it. It was messy, fragile, and just a nightmare to manage.
And this is exactly why databases were invented. They came in to save the day. They give us a structured, super organized way to store everything. They're built from the ground up to be incredibly fast for searching and finding things. They have security baked right in. And maybe most importantly, they make sure our data stays consistent and doesn't get corrupted, even if thousands of people are using the app at the same time. They're just the elegant solution to all that file-based chaos.
Okay, so we've established that we need databases. Great. But here's where it gets really interesting. It turns out there isn't just one way to build a database. There are 2 major competing philosophies, 2 different schools of thought. And this is the great debate in the data world: SQL versus NoSQL.
So first up, we have the original champion, SQL. The best way to picture an SQL database is to think of a really, really strict Excel spreadsheet. It has tables, and those tables have columns that you define ahead of time, like an ID column, a name column, an email column. And every single row, every piece of data you add must follow that exact structure. No exceptions. It's rigid, it's predictable, and for decades it's been the gold standard in systems like MySQL or Postgres. Its number one goal is consistency.
And then you've got the challenger, the new kid on the block, NoSQL. And it basically looks at all that rigidity and just throws it right out the window. Instead of strict tables, you have flexible documents. And you could think of these like a big file folder. Each document inside can have a totally different structure. So one user document might have a location field, but the next one doesn't. No problem. This flexibility is the absolute core of what makes NoSQL systems like MongoDB so powerful.
This little table really sums up the whole thing. First, you've got the schema, which is just a fancy word for the data's blueprint. SQL, as we said, has a fixed schema. You set the rules up front. NoSQL has a flexible schema, which is amazing for apps that change and evolve all the time. Then there's how they connect data. SQL links data across different tables using something called joins. NoSQL often just puts related data inside the same document. It's usually a lot simpler. But the last one, scaling, this is the big one. This is the real game changer.
Because scaling is maybe the single most important challenge any successful app will ever face. I mean, what happens when you go from 100 users to 100,000 or a million? Your database has to be able to handle that crushing load, and the way it does that is absolutely critical to your survival.
And there are really only 2 ways to scale. The first is vertical scaling. This is like buying a bigger, more powerful computer. More RAM, a faster processor. You just keep upgrading to a bigger box. But eventually, you hit a hard physical limit. You just can't buy a bigger machine. The other way is horizontal scaling. Instead of one giant supercomputer, you just add more and more smaller, cheaper machines to the team, and you spread the work across all of them. And the beauty of this is it's practically limitless. You can just keep adding more machines.
So here it is. This is the punchline. NoSQL databases were born in the internet age. They were designed from the ground up, from day one, specifically for horizontal scaling.
Because their data is stored in these nice, self-contained documents, it's super easy to split that data across thousands of different machines. This is their superpower. It's why they are so incredibly popular for modern, high-traffic web apps.
All right, enough theory. Let's make this real. How does this actually play out at the companies we all use every day? What are the biggest tech giants on the planet actually doing with their data?
Well, Netflix is the perfect case study. To track every single thing you watch, which is billions and billions of events a day, they need massive scale. So they use NoSQL. But for your billing info, the stuff that absolutely positively has to be correct, they use a good old-fashioned SQL database for that. Amazon runs its entire product catalog on its own NoSQL database. WhatsApp, with its insane messaging volume, runs on NoSQL. But what about your bank? You can bet they're using SQL. When it comes to your money, you can't afford even a tiny inconsistency.
And this is maybe the most important lesson of all. It's not really SQL versus NoSQL. The real world is all about SQL and NoSQL. The best engineers don't just pick a database because it's popular. They look at the specific problem they're trying to solve, and they choose the right tool for that specific job.
So, with all that in mind, let's bring it all the way back home to our project for this series, our Notes and Tasks app. Now that we know all this, what's the right tool for our job?
Well, let's think about what we need. We're going to want to add new features down the line, right? So we need a flexible structure. We're just starting out, so we want to be able to build and change things really fast. And hey, we're optimistic. We hope it gets popular. So we need something that can scale easily when we have a ton of users. And finally, our API is going to be speaking in JSON, which is pretty much the default language of the modern web.
When you lay out all those requirements, the choice becomes crystal clear, doesn't it? A NoSQL database, especially one like MongoDB that actually stores data in a format that looks just like JSON, checks every single box. It's flexible, it's fast to work with, and it's built to scale. It is, without a doubt, the perfect fit for what we're building.
So there we have it. We've got our application's brain, which is the back end, and now we have chosen its memory, our NoSQL database. The last big question is, how do we actually connect the two? How do we get the brain and the memory to talk to each other? Well, in our next session, we are going to do exactly that and finally see how data flows from end to end. We're going to turn all this theory into real working code. I'll see you there.